Welcome to Building and Shipping, CI/CD on AWS, Module 3, Episode 1. This video focuses on source control and branch strategy using CodeCommit. We will discuss how your branching strategy affects your release cadence, enabling product managers and engineers to align on shipping faster, breaking less, and avoiding merge delays. This program is brought to you by the Series of Thoughts team as part of the AWS for Product Team series.
In this episode, we bridge the gap between product management's focus on delivery speed and engineering's implementation of version control. We will cover the PM and dev angles on branching strategy, AWS services like CodeCommit and CodePipeline, and emphasize that your branch convention is fundamentally your intentional release strategy. From the PM perspective, your branch strategy is your release strategy. Branching is not just a technical concern. The way your team structures branches directly impacts how quickly and safely features reach users. Every branching decision has an immediate delivery consequence. We explore two dominant approaches, trunk-based development and feature branching. Trunk-based development involves short-lived branches, continuous deployment, and lower merge conflict risk, ideal for high-velocity teams. Feature branching uses long-lived branches, leading to higher merge risk, and is often tied to task completion, not code readiness. When you hear we're waiting on a merge, that's a process problem, not a people bottleneck. Long-lived branches lead to painful merges due to accumulating divergence. If your team consistently waits more than 24 hours to merge a completed feature, your branching model is slowing down delivery, not protecting quality. Branch strategy has significant effects on your roadmap and delivery goals. For instance, shipping a small fix today is easy with trunk-based development, but complex with feature branching. Similarly, rolling back a bad release is simpler with trunk-based due to its linear commit history. Switching to the dev angle, we begin with setting up CodeCommit. AWS CodeCommit is a fully managed, Git-compatible source control service. It offers no servers to manage, no storage limits, and integrates natively with the AWS developer toolchain, including IAM, CodePipeline, CodeBuild, and CloudTrail. Creating a CodeCommit repository is quick. The key setup decisions involve 1. Creating the repo, named after your service. 2. Configuring IAM access using repository-level policies and roles. 3. Choosing a connection method like SSH with AWS CLI. 4. Defining the default branch, which should be main and protected. If you are already on GitHub, CodePipeline supports it as a source provider, allowing you to mirror your GitHub workflow into the full AWS CI/CD toolchain. CodePipeline uses a GitHub connection via AWS CodeStar connections, which detects pushes and triggers the pipeline automatically via webhook, eliminating polling and delays. Branch protection rules enforce your branching strategy automatically at the point of merge. These rules can require pull requests for all changes, mandatory status checks to ensure CI passes, required approvals before merging, and that branches are up to date with "main" to reduce integration surprises. A good branch convention is short, memorable, and self-documenting. The recommended pattern is type/ticket-id-short description. Define branch types like feat, fix, hotfix, chore, and release. Map these types to deployment environments, for example, main to production, staging to staging, and feat/asterisk to ephemeral environments. Tying branches to environments is crucial. Branch names should clearly imply where the code lives. This diagram illustrates a typical promotion path. Feature branches merge to staging, which merges to a release branch for UAT and ultimately merges to the main branch for production deployment. The pipeline enforces this path. Commit message standards are vital, as they create your changelog, audit log, and onboarding guide all at once. Poor commit history makes debugging and rollbacks difficult. Standards are not bureaucracy. They are documentation that writes itself. Conventional commits is a widely adopted specification for structuring commit messages. The format is type, scope, description, optionally followed by a body and footer with ticket references. Enforcement can be managed with a pre-commit Git hook, like "commitlint," or a code build validation step before merging. Connecting commits to tickets ensures traceability, answering why code exists months later. Linking commits to ticket IDs makes every change auditable. This I implemented by including the ticket ID in the commit footer, using a commit MSG Git hook for validation, and adopting a clear PR title format for automated release notes. CodeCommit is integrated with AWS CloudTrail out of the box, logging every API call to your repository. This is an operational tool for understanding what changed and when, not just for compliance. CloudTrail logs branch creation, pushes, policy updates, and access attempts. CloudTrail allows you to alert on anomalies, routing events to CloudWatch logs. For example, an alarm can trigger if a force push bypasses PR protection. This enables immediate rollback, providing a complete, tamper-proof record of what happened. Enable CloudTrail in every AWS account by default. A recommended setup involves 5 steps. First, create your repository and enable CloudTrail logging immediately. Second, define your branch structure, mapping main, staging, and feature branches to environments. Third, apply protection rules requiring PRs and approvals to main and staging. Fourth, adopt commit standards like conventional commits and require a ticket ID. Fifth, achieve team alignment by documenting the convention in your README and reviewing it with PMs and engineers during sprint planning. Explicit convention is always better than implicit process. Avoid common anti-patterns like the immortal branch, where code lives too long and leads to merge nightmares. Avoid the unnamed branch, which lacks ticket references and purpose. Also, avoid the unprotected main, as untested code can reach production, risking instability. Lastly, avoid the environmentless convention, where engineers don't know where their code lives. The branch strategy conversation is vital. This discussion, often skipped by teams, impacts delivery metrics. Setting aside 30 minutes to align PMs and engineers on conventions pays dividends in every sprint that follows, ensuring everyone is on the same page regarding the release mechanism. Product managers should be able to answer 4 basic operational questions. What is our branching model? How long do branches live? What blocks emerge? And how does code actually get to production? These answers provide visibility into the release cadence. Engineers want PMs to understand the pressure trap. Delivery pressure can encourage shortcuts that accumulate technical risk, leading to production incidents or painful rollbacks. The ask is to respect the PR process, size features small, and include branch health in sprint reviews. Feature flags bridge the gap between branches and features, allowing code to merge continuously before a feature is visible to users. This decouples deployment from release, enables controlled rollouts to specific user segments, and supports built-in A/B testing, letting data drive shipping decisions. When choosing your source of truth, compare CodeCommit and GitHub. CodeCommit offers first-class IAM integration and data sovereignty within your AWS account. GitHub is the industry standard with feature-rich PR/review UX. CodePipeline integrates well with both. CodeCommit's deep IAM integration is a major advantage. CI/CD systems should use IAM roles, removing the need to rotate credentials. Human access is controlled via IAM policies, scoping permissions to specific repositories or branches. Enforce MFA for sensitive operations like pushing to protected branches. Measuring branch health is critical. Target a branch lifetime of less than 24 hours. Aim for a PR review cycle time under 4 hours. Keep active branches per engineer close to 1. And most importantly, strive for 0 unprotected pushes to main, tracking every process violation. The key takeaway is that your branch convention is your written release strategy. Define the convention explicitly, enforce it with tooling, and ensure PM and engineering teams are aligned on its meaning for delivery. Structural fixes prevent slow delivery and high risk. In summary, PMs should remember that branching strategy affects delivery speed, and feature flags separate deploy from release. Engineers should immediately set up branch protection, adopt conventional commits, map branches to environments, and enable CloudTrail. This episode covered CodeCommit, CodePipeline with GitHub integration, and CloudTrail. Up next in M3E2, we'll dive into code build, covering how to turn a commit into a validated, deployable artifact through automated testing and smart build pipeline design.